Hello everyone, welcome back to Day as a Professional. And today I'm here with Mr. Vish Turaga. He's a professional in the semiconductor industry. How are you doing here, Mr. Vish?
I'm doing good, Gautam. How are you?
Thank you for taking time out today to come and talk to me. And yeah, let's get straight into the questions. How would you say you initially got interested in this line of work?
So a lot of it has to do with the branch of engineering that you pick with. And for me, I was interested in the electronics industry, and I started with that. And the way I see it is, semiconductor industry is a natural transition when you start in the electrical electronics industry, and that's how I got started in this world.
Hmm. And what is some key interests which really got you into engineering or electrical engineering in particular?
I think it's also the I was basically interested in math and sciences, and engineering is the next step for it. So,
Yeah.
I think that's how it started. It's like, you're interested in engineering and math, and in the physics, chemistry, those kind of subjects,
Hmm.
which lead you into this industry.
Hmm. And what do you say are some key skills which are really required to become a professional in the semiconductor industry?
Um, I would say, like, like you pick any field, right? It's about the discipline and how much time you're willing to spend in understanding a concept. I
Hmm.
don't think there's any majorly different skill you need. It's your persistence of picking a field, and how long you can stay with it. Like,
Hmm.
any you can pick any field. You'll start on it. Some things may come easy, some things may be a bit harder, but it's about your perseverance of how you can
Hmm.
push through those times when you don't understand it. Maybe you have to read something 2 times, 3 times. It's about that persistence.
Hmm. And what would you say, how would you say, I mean, you said that going to the semiconductor field is like naturally coming through the electrical engineering field. So how would you say in particular which aspects of electrical engineering is most prevalent in the semiconductor industry?
So if you so maybe we should define what we mean by semiconductor industry, right? If you think about it, look around you. Anything that you take your phone, your TV, things in car, anything that has, if you press a button, something happens on the screen or anywhere, it goes through. There is definitely a component of semiconductor. You take your
Hmm.
phone chips. I mean, you're super young, you probably may not know it, but in our time, let's say you've seen how the phones, even within your generation, you have seen how the size of the phone, how it has become smaller.
Hmm.
The phones have become thinner and thinner,
Right,
right?
right.
All of that is what we are seeing come from the semiconductor industry.
Hmm. What the is like the shrinking of more information into a small space?
Small space. I mean, at the end of it, right? It's how would you define in layman terms? It would be like anything that you see on the screen. It is,
Mhm.
I think, again, to you understand the concept of digital, right? Digital is basically, it's a 0 or a 1.
Right, right.
Anything that you see on the screen is basically some representation of a 0 and 1.
Hmm.
And the semiconductor industry, now imagine you have to put in a huge amount of information. Let's say if you could only talk in zeros and ones, at
Yeah,
the end, the chip is just that.
right,
What you
right,
see on your phone, the only thing it understands is either a 0 or a 1.
right,
So
right.
everything that you see has been converted into that zeros and ones.
Hmm.
And and the whole semiconductor industry is about how do you communicate that more information in the smallest space.
Oh, okay, okay. And that's how you
And
can see more smaller iPads or like bigger iPads, smaller
yeah, I mean,
phones.
yeah. So the way, yeah, screens are becoming bigger, but have you seen the first iPad that you may have played with? How thick it was and how much
Right.
it is now?
The
In
processing
the
speed
first,
was much less.
yeah, I mean, we are having a Zoom call now,
Hmm.
right? And there's some amount of information that is being transferred into the device. It's your audio is transferring. Everything that you see today has an underlying of the semiconductor industry.
Hmm. And I want to like talk about where do you think the semiconductor industry will be in the future? So right now we can see how it's transitioned from even as far 2004 to what it is right now. from iPads with much less processing speed, and now we can see iPads which have a processing speed rivaling computers back in 2004. So how would you say it will continue to build in the following years?
I think it's a journey. I don't think it'll ever end. Right? I
It'll,
mean, there's
mhm.
always yeah, take the resolution of it. Do you play video games?
Yeah, I do.
So now you've seen, like, can you play a video game which was, say, 5 years older or 10 years older? You'll say it's too
Okay.
slow. The objects are
Yeah,
not moving. It's not clear,
right,
right?
right,
So all of that is a result of the advancements in semiconductor industry. And would you ever want to say that, oh, I don't need things to move faster. I don't things need to be clear. You'll never reach that stage,
right. You
right?
just want to keep on
So
doing it faster.
you want it faster. You want more clarity. I mean, the video game that you play today is
Mm-hmm.
significantly different than what you even played last year, right?
That's true. That's true.
And do you think you're satisfied with this, or if a new video game comes, you would want to go buy the new one,
Right,
right?
right.
So in that sense, I don't think there's an end to the semiconductor industry. You'd always want more things,
Mm-hmm.
faster and different aspects. I mean, you have an Alexa in your home today, Alexa or a Google Home device.
Mm-hmm.
A few years back, that was inconceivable, right? Nobody could think that you would depend, what's the temperature outside. You talk to your
Right.
phone things. So those
Mm-hmm.
advancements will keep happening. So it's a great industry to be in. If anybody's thinking of getting into the semiconductor industry, it's an awesome industry. It's an ocean where you can continue learning all your
Whatever you
life.
need to do.
Yeah.
Mm-hmm. And how would you say you also have an MBA in general management marketing? How would you say that really affects you in your work life?
Um, I I feel like it's MBA or any of these kind of degrees. What it does is it gives a structure to your thought. At the end of it, right, whether it is semiconductor or whether you're in the computer industry or finance industry or any industry, you have a task which would take a year. Now,
Mm-hmm.
how do you organize yourself and make sure that you're able to get that accomplished in a given time?
Right, right.
Right. Take yourself for example, right? You have, let's say, home. You have, like, let's say you're studying 5 subjects and you have homeworks in 5 subjects and you have 1 week. You put some kind of a plan, right? Maybe you don't document it, but you put a plan that I need roughly
It's
3
done by
hours,
this day.
right?
Mm-hmm.
And so the MBA, at least in general management, and again there are specialization in MBA also. I'll talk about general management. It's about putting a structure to what you want to accomplish.
Mm-hmm.
But what is at the base of it is you still need to understand what you're trying to do. If you're trying to, in the semiconductor, unless you're trying to build a chip, you have to have a good understanding of what are the different fields of it. And that's after that is the MBA's skills come handy.
Right, right.
So again, there are some industries where, if you take an MBA, right, I could have specialized in finance, I could have specialized in marketing or different aspects of it. But
Mm-hmm.
for me, it was to be able to get a better structure and thinking in terms of making sure a semiconductor, a chip project gets done well. That was what my motivation was.
Mm-hmm. And going back to chip processing and the semiconductor industry as a whole, what do you say is some good coursework to take in college to really get you acclimated to some of the things you'll face in the industry?
Oh, that's a very good question. And I think, anybody who's anything related to either the software, computer engineering, even physics or math, in some ways, I feel there are few courses which I think are very basics. I mean,
Mm-hmm.
a basic course in digital electronics is absolutely critical. If you remember, I was
Right.
giving you the example of everything is being stored in terms of 0 and 1.
Mm-hmm.
That is the
Right.
crux of all of electronics. And there are a lot of classes. I think you probably will, maybe in sophomore year, you'll start taking those classes, is basic concepts of digital electronics, what
Mm-hmm.
it is, how does it work. So that, I think, is a very fundamental course. But once you take that course, it gives you a very good insight of how the world of electronics actually is. So
Right.
that's one course I would say for sure. And again, like, the semiconductor industry, I feel, is a combination of it picks every industry. You should be able to program if you want to be in the semiconductor industry. You'll touch upon, like I said, digital electronics, you'll touch upon chemistry, you'll touch upon physics. All these courses are what you'll see when you get into the industry. You'll use almost every of this course.
And in particular in programming, what programming language would you say you would need to like know the most? Or is it just like every like basics in every knowledge in every language?
Again, it's when you see that's a very to understand what language you need. I think that's not how you should approach it. What the way you have to approach this industry is, what does programming do? Programming, in some ways, you can also think of it as it's a way you handle repetitive tasks. How do you do automation, right? I mean, you are, there's a certain processing you're doing and it is happening in a certain pattern. So what you need to understand is the logic behind it. You have a logic in your head. How do you implement it? Now, what language you choose can be different. You can pick any language to start with.
Right.
But you have to get the basics of, okay, I'm sure you've started some programming, understanding, say, the for loop, the loops. How do you, so programming, I don't think you should approach it in a way that what language should I learn? Pick any programming language, get comfortable with it. After that, it's about,
acclimating it to that.
The language. So that's how you should approach this.
And what would you say is the hardest component of your job?
See, okay, I'll answer it in two ways. I will leave. So there will be technical challenges. There will be, other non-technical challenges. But the hardest thing when you start working in industry is the choice of what to do and what not to do. That becomes the hardest thing. Because I was giving you the example of, you're taking of a video game example, right, or an Apple iPad.
Right.
You have to, you may want to do 600 things, but there's a time constraint to it.
Right.
Now, let's say if I say the iPad was supposed to release in end of this year, and I'm trying to do 600 tasks in it, whereas I could have done only 400. What will happen? I won't release it end of the day.
Right. Because you don't have enough time.
Yeah. So the balance or the toughest thing in the job becomes is, how do you make sure you do as much as possible in a given time? Because when you start working in the industry, what becomes critical is you have to get to bring the maximum amount of improvement and at a given time. Because if I give you unlimited time, you can do anything. But that's not how the world works, right? If I tell you have to give a product at a certain time. So it's understanding that balance is very tricky.
So what I'm hearing is that you need to have good prioritization, good organization, and knowing how to complete tasks on that, time management skills.
Absolutely. I think that is that. And a lot of times it's about what not to do, right? And that's a very hard thing to identify.
And would you say some of these skills you had learned throughout the course of your career, or would you say that that's something you learned coming straight into the industry, or can you give me some other things which you learned throughout your career rather than at the beginning, if that makes sense?
Yeah, I think that's again a good question. So there's some things which you learn by getting burnt or having maybe early in the career, you're super enthusiastic. You say, yes, I'll get this done in a certain time, and you may not get it done. Right. So some things you learn over the period of time. But what I think is a critical element is having the understanding that when you look at a task, right, you shouldn't just stop at the end of the task. What you have to understand is what is the implication of the end goal. Like for example, right, you've been asked to say, it's a very simple task. Let somebody said, okay, can you go turn on that switch or turn off that switch? It's a very mundane thing. You can go do it. But what you have to understand is what's behind it. Why is that being asked of you? You have to understand. It could be maybe it's you're launching the rocket with that ship, or maybe you're just turning on the light. If you understand the context, that makes you aware of the consequences, and your decision making will improve through that, and the prioritization will improve. Right? Again, it's a very lame example, but if you take those two extremes, if it's just turning on the switch so that light comes, you're like, okay, I can do it in, even if I am like half a minute late, it's fine. But if it is something super significant, no, you have to. So the prioritization comes when you understand the overall scope of it. So could you learn this early in the career? Sure, there are people who are much smarter, much aware of things, but some things you learn with experience. But you're young, so the main feedback would be understand the full context of what you're doing.
And what do you say are some daily responsibilities you have from as soon as you walk into your office to when you leave?
See, typically, right, and this becomes part of, it doesn't matter whether it is semiconductor industry or any industry, right? The task that you have sometimes takes, your end goal is like almost a year later is when your product will come out, year or 2 years later, depending on what product you're working on.
Right.
So you have to figure out, how do I plan for something that's going to take 1 year's worth of work, right? It's 1 year's worth of work, but you break the task into something that I need to get done at the end of 3 months. Then you break the task, what do I need to get done end of week? And then the job becomes, you have to make sure you continuously make progress. Sometimes it is, you have a very, very hard technical problem for which you may have to talk to 20 other people who are the experts in the industry. You go talk to them, get their opinion. Based on that, you make a choice and you fix that problem. So the day is very different, but the goal is to make progress towards your end goal. And a lot of times it is, a day could be where you are, sitting and solving a very deep technical problem, or the day could be maybe you are looking at some logistic aspect. Right? So the day is never fixed, but what you have to see is, am I marching towards my end goal?
Right. And if you could describe how you've worked on previous projects and what was the end result of that?
The products are not out, so I don't want to tell about the specific products, but I'll tell you what happens with a typical chip design, right? It starts with a concept of how let's take your video game for an example, right? You look at your video game and you look at your refresh rate, frames per second. I'm sure you are very aware of it, or you want to look at the processing speed. Let's say it's a gigahertz is what you're targeting. The work starts is the next generation. When I release the next update of your video game, if I give you the frequency at the same number, you won't be happy, right?
Because nothing has changed then.
Nothing has changed. Why would you buy it, right? You won't go buy a video game if it's very similar to it. So a lot of times the number that it becomes very attractive for people is 30% improvement, roughly. That's the number which a lot of people in the from generation 1 to generation 2, they want at least 30% improvement. Right? So you want to be 30% faster. Now to do that, every component has to become faster. Right? So that's how the project starts, is you start with, that's my end goal. And then you look at the project could be made of 20 different components. Then every component has to get equally speeded up. Right? It doesn't work, right? Let's say if you have 4 parallel things going, if 3 of them have gone fast and 1 of them hasn't, your product still hasn't become fast. It doesn't work. It'll still be at the slowest speed. So that's kind of how we approach it. So, the start would be, you put a target, and my end goal was, we reached that. I know I
Mhm.
didn't give you a specific example of what I worked on, but that's how every product would work.
Yeah, that's fine. But a question adding on to what you just said, what components in particular would you have to speed up, and how would you speed them up?
Okay. I don't know how much depth you want me to go, but it probably will be a refresher of like a 101 for a water chip design. Um, I'm
Sounds
trying to
good.
see what would be the simplest way to explain how a chip works.
As much
Um,
detail as possible.
what's
It
that?
works for me. As much detail as possible works as well. So.
Yeah, no, I think I don't want to get into so much details. Um, so let's think about it like, like I told you, right? Everything is represented using zeros and ones.
Mhm.
Now, when you look at you're seeing me on the screen, right? Now,
Mhm.
if you want it more cleaner, let's say if I draw your, do you understand what pixels are?
Yeah, yeah.
So pixels, imagine like, if I have a screen and I have divided it into say 100 equal units, and
Mhm.
based on that, I color either a black or a white or I put the color to it, each one of them.
Right, right.
Now, if I increase that from 100 units to 1000 units, you'll see the picture a lot more clear,
Mhm.
right?
Right. Mhm.
And now if I make it to 10,000, you'll see even more. So
Mhm.
that in one way is what chip design does. How many images am I breaking a picture into? How many pixels am
Mhm.
I breaking into? So that's one metric. So now to do that, you can think about it, the display, right? That's what you're seeing. It is breaking the screen into 100, then it has to go into 1000, then into 10,000. That's how the resolutions are increasing. That's one
Mhm.
vector. So now there will be a team which will be looking at how can I send more data? Because if you are only 100 boxes, I have to
Mhm.
send 100 units of data. Now, if I
Right,
break it
right.
into 1000, I have to send 1000 data. And you have to also imagine everything is like, it's the example could be like you are building a pipe where you are
Mhm.
sending information. Now, if I'm sending 100 units of data, the pipe can be 100 units
Right.
worth. Now, if I send
Mm.
1000,
It
somebody
has to
has
be
to
a
make that
thousand.
pipe bigger,
Mhm.
right? So I know I'm not talking in terms of semiconductor, but that's how you have to see. So that particular aspect has to be, and all of that data has to fit in that small chip,
Mhm.
right?
And has to function also.
Everything and function. So now what happens is, if you notice your iPad hasn't suddenly become too thick. So in the same space, somebody has gone and fitted 2x the amount
Right.
of
Processing speed or pixels
processing
or
in the same chip. So I mean, if you are interested, you should read up on what do you understand what Moore's law is?
no, I don't believe so. I have to read
Yeah,
up
just
on
just read up on that, and it is probably one of the most fundamental. It's called as a law now, which has governed the semiconductor industry for the last 40 plus years.
it.
So
Okay.
this is one of the Intel's founders. He came up with this concept that every 1.5 years, the number of
Mm.
devices that you put in a single chip, number of cells you put in a chip, doubles.
Oh, so like
So
that's how it keeps on.
yeah,
Okay.
so every 1.5 years, the amount you put in a single chip. Let's say if you were putting 100 devices before or 100 cells,
Mm-hmm. Has to be
every
200.
1.5 it doubles. Yeah,
Oh, wow.
and that is not the surprising part. The surprising part is he came up with this 40 years back,
Uh-huh.
and it has stayed true till today.
Mm-hmm. And you can still see it like people
Every
it's
year
keep on.
you can go back. It's roughly the same. So
Mm-hmm.
yeah, you should.
When was the last what do you call it, the slot? Because you said every 1.5 in year interval. So when was the last interval? When did it end?
So the thing is, you it's on the time unit. So whenever you say that, let's say if I have released a product now, the next product that I released will have almost 2x the
Oh,
number
okay.
of
So
them.
that's about 1.5 years.
Yeah, so that's how they
Oh,
say it. Yeah.
oh, okay, okay. And how would you say high school students can get more involved in the semiconductor industry or electrical engineering, which can further go into the semiconductor industry?
I think I've seen a lot of people get into robotics. That's one very simple way to get into it.
Mm-hmm.
People have seen a lot of companies, they give these design kits like Arduino kits,
Mm-hmm.
where you write programs and you can build products using that. That's one
Mm-hmm.
good way. And even just taking an interest in the configuration of your machines.
Right,
I mean,
right.
you have I don't know if you have a laptop or a desktop. Desktops are easy. Open it up, look at what are the components in it, see if you can upgrade it. That's how you'll build interest into this field. You'll start
Mm-hmm.
understanding some of the terms. Let's say, what is the graphics speed for it? What processor am I using? Which generation is this?
Mm-hmm.
So I think the first part is, what they say is get your hands dirty with, either looking at your,
Phone or like the
yeah, I mean,
household
if you can,
device.
I mean, ripping out a phone might be expensive, but sure, you can go open up an old phone. Don't try this with your brand new phone. But yeah, I think just take an old electronic device which you think is expendable and just open it up and see what are the different components. That can be
That's
very
right.
fascinating.
Mm-hmm.
And even
And
programming, right? Programming, any programming that you do will come handy.
mm-hmm. And yeah, those are all the questions I have for you.
Awesome.
Thank you so much for coming and talking to me. If you want my email, it'll be in the description. If you have any questions, let me know. Please like and subscribe. I'm almost at 1,000. And peace.
Thanks, Gautam. Thank